Quadratic equations. We must know that a quadratic equation is one which can be written in the general or standard form ax squared plus bx plus c equals 0, where a is not equal to 0. If a was equal to 0, this x squared term wouldn't exist, and this would simply be a linear equation of the form bx plus c. Basically, a quadratic equation is any equation containing one term in which the unknown is squared and no term in which it is raised to a higher power. When we talk about the general or standard form, what we mean is the terms are put in this particular order. So we have our x squared terms, followed by our x terms, followed by our constant terms, and we have this always set to 0. This is something we should be checking at the start before trying to solve a quadratic equation. Consider the following equations. Which equations are quadratic? Let's start with this one here. 4x plus 3 equals 0. This equation has no x squared term, and it's in the form mx plus c. This is a linear equation and therefore not a quadratic equation. Over here we have an x squared term, and it is the highest power of x. So we should be able to rearrange it into the form x squared plus 5x minus 5 equals 0. So this is now a quadratic equation in general or standard form. This one here is obviously a quadratic equation, and it's already in our general standard form. X squared minus 3x plus 3. So our x squared term, our x term, our constant term, and set equal to 0. Let's take a look at x squared equals 9 next and start to try and rearrange it. So x squared minus 9 equals 0. This is a quadratic equation in general or standard form. We have our x squared term. We don't have an x term here, but that doesn't matter. And we have our constant term, and it's set equal to 0, so that's fine. In this example it looks a little bit different, but if I start to try and rearrange it into general form, we end up with multiplying through by 5, x squared plus 2x equals 35, which we can then rearrange to x squared plus 2x minus 35 equals 0. So again, a quadratic equation in general or standard form. Next, looking over at this one, this is not a quadratic equation. The reason being the highest power of x here is 3, so because we have an x cubed term here, this isn't a quadratic equation, this is in fact a cubic equation. We'll now move on to solving quadratic equations by factorising. This is based heavily on the idea that if a times b equals 0, then either a or b must be equal 0. In other words, if we multiply two things together and we get 0, then at least one of those two things must have been 0. Consider these. In the first example, 5 times some unknown value is 0. The only thing this unknown value can be is 0. In this example here, some unknown value multiplied by 4 gives you 0, and we should know that the only thing this could possibly be here, again, is 0. In the last example, two unknown values multiplied together to give 0. Now, not both of them need to be 0, but at least one of the two does need to be 0. We'll now try a few examples. The first example, we're being asked to solve 5x squared minus 20x equals 0. So we have our quadratic equation in standard quadratic form. So we have our x squared term, our x term. In this case, there is no constant term, so that can be considered 0. There's nothing there where c would normally be. And our equation is set equal to 0. So we're going to go through our factorising checklist. The first thing we check for is there a common factor. 5x squared minus 20x, there's a common factor of 5 from 5 and 20, and a common factor of x from x squared and x. That will leave us with x minus 4 in the bracket, and we'll keep that set equal to 0. What we now have is our a times b equals 0. In other words, this 5x is multiplying this bracket. So 5x multiplied by this bracket equals 0. Therefore, either the 5x must be 0, or the bracket here, x minus 4, must be equal to 0. So what we can do is split that into two separate equations. So 5x equals 0, that's one possibility, or x minus 4 equals 0 as our second possibility. Each of these can be solved in the normal way. 5x equals 0, divide both sides by 5 to get x equals 0, and this second equation, x equals 4 by adding 4 to both sides. This gives us our two solutions to our quadratic equation. Let's now try these two examples. Part B, 4x squared minus 81 equals 0. First, let's check that it's in standard quadratic form. So we have our x squared term. There is no x term, but that's okay. And we have a constant term and set equal to 0. So ready to go. We'll start off by going through our factorising checklist. 1, is there a common factor? In this case, no. Is there a difference of squares? Let's have a look. We have 4 is square, and x squared is obviously square. 81 is a square number, and it's minus, so a difference of 2 squares. So we can start to factorise that. Difference of squares, remember, goes into 2 brackets. And we have the square root of 4x squared is 2x. That goes in at the front of the brackets. And the square root of 81 is 9. That goes in at the end. And difference of squares, as always, 1 plus and 1 minus. Now, again, we have 2 things here, which are multiplying together and equal to 0. So this bracket multiplied by this bracket equals 0. Therefore, either this bracket is 0, so 2x plus 9 equals 0, or 2x minus 9 equals 0. Again, each of these can be solved in the normal way. So subtract 9 from both sides, 2x equals negative 9, divide both sides by 2, negative 9 over 2. It can be left like that as an improper fraction. Over here we have 2x minus 9 equals 0, so therefore adding 9 to both sides, 2x equals 9, dividing both sides by 2, x equals 9 over 2. And here we have our 2 solutions of this quadratic equation. Looking at the next example, part C, we have x squared minus 5x plus 6 equals 0. Again, a quick check, it's in our standard quadratic form. So we have our x squared term, our x term, our constant term, and it is equal to 0. So ready to start to factorise. First thing, is there a common factor? In this case, no. Second, is it a difference of 2 squares? There's 3 terms there, so definitely not. And lastly, is it a trinomial? Which, yes, it is. So we're looking for a factor pair of 6 with a sum of 5. So 2 numbers that multiply together to give 6, but add to give 5. So that's going to be 2 and 3. They multiply together to give 6, but they add to give 5. Now my target number here is negative 5. So I need to use this 3 and 2 to make a total of negative 5. So we're going to go with negative 3, take away another 2, giving me negative 5. We now have, again, this bracket multiplied by this bracket equal to 0. And therefore, we can split it into 2 parts. Either x minus 3 equals 0, or the second bracket, x minus 2 equals 0. Solving each of these, x equals 3 and x equals 2. And again, 2 solutions to that quadratic equation. Next, we'll look at solving 2x squared plus 5x minus 12 equals 0. Again, go through the usual checklist. Is there a common factor? No. Is there a difference of squares? No. Is it a trinomial? And the answer is yes. It's one of the harder trinomials. So what we can do then is start off with our 2 brackets equal to 0, and 2x squared here, that can only be made up with 2x multiplied by x. And then what we're looking for, remember, is factor pairs of 12, so 1 and 12, 2 and 6, 3 and 4. And what we want is the inner product, these 2 multiplied, and outer product to have a difference of 5x. So we just try them in different places until we get one that works. So we might start by trying 1 and 12, which would give us inner 1x, outer 24x, and they don't have a difference of 5x. So we could try them the other way around, 12 and 1, 12x and 2x, again, doesn't work. As you get better at this, you'll start to work out which numbers are going to work, but if in doubt, just do it one at a time. We'll try, let's see, 4 and 3, and that gives us an inner of 3x, and outer of 8x, and they do have a difference of 5x. The next thing is to say, well, my inner product here is 3x, and my outer product is 8x, and my target is positive 5x, so positive 5x down here. Now to get positive 5x, that's positive 8x, take away 3x. So if I want negative 3x, my inner product will need to be negative 3 times x, and if I want positive 8x, my outer product will be 2x multiplied by positive 4. Again, we'll break it into 2 equations, so either 2x minus 3 equals 0, or x plus 4 equals 0. So 2x equals 3, meaning x equals 3 halves, or x equals negative 4. Okay, next part E, we'll look at, again, going through our checklist. 1, is there a common factor? The answer here is definitely yes. 6 is a common factor, leaving me x squared minus 4. Second thing on my checklist is there a difference of squares? And again, yes, that bracket there is definitely a difference of squares. So x minus 2, x plus 2 equals 0. Now, here we have 3 different parts. We have 6, this bracket, and this bracket, all multiplying to give 0. So, normally when there's 3 parts multiplying together 0, each of them could be made equal to 0. But obviously 6 here, 6 can't ever equal 0, and therefore we can just ignore that one and take these 2 parts here and make equations with those. So, x minus 2 equals 0, or x plus 2 equals 0. So x equals 2 or x equals negative 2. We're now going to look at solving quadratic equations where the equation's not written in standard or general quadratic form. So basically remember, standard or general form is the form ax squared plus bx plus c, and it must be set equal to 0. In other words, our x squared, our x are constant and equal to 0. Over here, this is not the case. We have an equation, it's got an equal sign in the middle, and we can tell it's a quadratic equation because x squared is the highest power of x here. But we'll need to rearrange it first of all into standard quadratic form before we can start to solve. So, start by taking away 7x from both sides. So x squared minus 7x plus 12 equals 0. And you'll notice I'm putting that minus 7x in the correct position within the standard form. And then we just go through our normal process as we've done on the last few parts. We go through our checklist. Is there a common factor? No. Difference of squares? No. Trinomial? And the answer is yes, and it's one of the easier ones. So a factor pair of 12 with a sum of 7. So that's going to be 3 and 4. X and x. My target here is negative 7. So I need to make it negative 4, take away another 3. Once again, that splits into our 2 separate equations. X minus 4 equals 0, or x minus 3 equals 0. So x equals 4, or x equals 3. I'll now try example B, where we have to first of all make sure we rearrange to get into this form. Now, because it's clearly not in standard quadratic form, we have these brackets to multiply out, so we can do that first, and then we'll start to bring everything across to one side, so we have it in this form. You'll notice here the variable is y. That shouldn't make any difference, it's still a quadratic equation. So multiply out the brackets first. That's negative 8y squared, multiplying these two, and negative 8 times positive y is negative 8y. I've then got to try and bring everything across to the left hand side, so I'm going to end up with positive 8y squared plus 8y plus 2 equals 0. So what all I've done there is added 8y squared to both sides, so this will disappear from the right hand side and appear at the left hand side. Add 8y to both sides, so this will disappear from the right hand side and reappear here at the left hand side. And then this positive 2 is already here at the left hand side, and we'll have that equal to 0 now. When I start to solve this, I'll need to start by factorising in the normal way. Starting off by checking for a common factor. I've got 8, 8 and 2, so there's a common factor of 2 there, leaving me 4y squared plus 4y plus 1 equals 0. That's my first check, is there a common factor? And yes, the common factor of 2. We're now looking at a difference of squares. The answer is no. And 3, is there a trinomial to be factorised there? And the answer is yes. Inside that bracket we've got a harder trinomial. So that's 2 brackets for that. Now, for 4y squared, we've got a bit of a problem. We can do that with 4y times 1y, or we can do it with 2y times 2y. If one doesn't work, you just go on and try the other. I'm going to start with 2y multiplied by 2y, and we're going to start to say we're looking for a factor pair of 1 with inner and outer products having a sum of 4y. Now there is only one factor pair of 1, so it's got to be 1 and 1, and my inner product therefore is 2y, my outer product is 2y, and there we can check that our inner and outer products do have a sum of 4y. What we notice here is it's positive 4y is my target, so positive 2y plus another 2y meaning both signs will be positive. Again, we've got three parts here. We have R2, our bracket, and our bracket equal to 0. So these three things multiplying to give 0. Now normally when three things multiply to give 0, then at least one of the three things must be 0. However, this 2 here obviously can't be 0, so we can just ignore that. Either this or this must be 0, so we can create our two equations. 2y plus 1 equals 0, or 2y plus 1 equals 0. Both these equations are the same, so obviously they're going to give us the same solution. This is a repeated root, and we could just leave the answers like that.